Let's solve this system of linear equations in 3 variables. We will again work with a pair of equations at a time to eliminate the same variable. That will create 2 new linear equations in 2 variables. Then we'll go from 2 equations in 2 variables to our 1 equation with 1 variable. We can get our numeric answer, work our way backwards to find the numeric answer for the other 2 variables. Well, I noticed right away, if I add those 2 equations together, won't the y terms disappear? If I add equation 1 to equation 2, instantly the y's disappear because they have additive opposites as their coefficients in those 2 equations, and that will create a new equation that only has x and z. So 2x plus x is 3x, minus y plus y disappears, plus 4z plus 2 more z is plus 6z equals 7 plus 2 is 9. And I now have a linear equation that only has x and z. Let's work with a different 2 pairing to see if we can eliminate y again. Well, how about if I take equation number 1 and multiply it by 2? That would make this coefficient minus 2y, and if I then added that to this equation, the plus 2y, the y's disappear again. So I'm going to take equation number 1, multiply every term by 2. 2 times 2x is 4x. 2 times minus y is minus 2y. 2 times plus 4z is plus 8z. And 2 times 7 is 14. Now let's add equation 3 to that equation. That's x plus 2y minus 2z equals negative 1. So 4x plus x, that's 5x. The y's disappear. Plus 8z minus 2z is plus 6z. 14 plus negative 1 is 13. So now I have these 2 equations to work with. And I can work with them to try to find a value for x or z, whichever I decide, by eliminating one of those variables. Let's multiply this equation. Let's multiply this equation by negative 1. And we'll add it then to this equation. Negative 1 times 5x, that's negative 5x. Negative 1 times plus 6z is minus 6z. Negative 1 times 13 is negative 13. Always remember to multiply by the constant. Easy place to make a mistake in solving these systems of equations. Now if we add, we have what? Negative 2x, that's 0, equals negative 4, so x equals 2 when I divide both sides by negative 2. And we now have our x value. So let's take our x value, and let's put that x value into one of those equations that just has x and z. How about if we put it into this equation where we have 3x plus 6z equals 9. 2 put in place of x, that's going to give us 6x. So we'll have 6x, oops, excuse me, that won't give us 6x, it'll give us 6. 2 put in place of x, 2 times 3 is 6. 6 plus 6z equals 9. Subtracting 6 from both sides, 6z equals 3. Oh, so z equals, a fraction, 1/2. Might make us wonder if we're right. But everything we did looks good, so we can have answers that are fractions. We prefer answers that are whole numbers. Fractions make us a little uneasy, give us the willies sometimes. But if we divide both sides here by 6, 3/6 is 1/2. So now let's take the value of x being 2, the value of z being 1/2. Let's go back to that first equation. If I put x being 2, so that's 2 times 2 minus y equals 4, whoops, not equals, not yet, plus 4 times 1/2 equals 7. 2 times 2 is 4, minus y, plus 4 times 1/2, that's 2, isn't it? So minus y plus 6 equals 7. So minus y equals 1. So y equals negative 1. And our ordered triple solution for this system of equations is x is 2, y is negative 1, z is 1/2. And we have solved another system of linear equations that was 3 equations with 3 unknowns.